This is Unit 11, Lesson 2, finding the nth term of arithmetic and geometric sequences. In this section, we're going to talk about different formulas and how they can be used to find specific term numbers. And these formulas are all the formulas that we're going to learn or use in this chapter. It's really important that you understand you do not have to memorize these. I would write them on a piece of paper somewhere and have them available for every homework assignment, every quiz, every test that you do. Even if you have to take the SOL, the formulas will be given to you. What you need to understand is how to use the formulas in a problem. And so all of this stuff that you see right here is going to be given to you on the SOL formula sheet. And for my tests and my quizzes, you can still use your formula. Everything for the formulas, at least, will be given to you. So if you look up here, they even tell you what each of the variables in the formulas mean. So a sub n represents the value of the nth term. Sometimes we refer to that as the last term or the term that we're looking for. S sub n represents the sum of the first n terms. We'll get to series later in the chapter. S sub infinity represents the infinite geometric series, and that we learned that toward the end of the chapter. R represents the common ratio. D represents the common difference. And the two formulas that we're going to learn today, or learn how to use today, are the a sub n equals a sub 1 plus n minus 1 times d. Formula a sub n equals a sub 1 times r to the n minus 1. In these formulas, a sub 1 is always the first term of the sequence or series. So a sub 1 is the first term. N is the term number of the term that we're looking for. So if they say find the 10th term, then N in that case would be 10. D is the common difference, R the common ratio, and we learned about the common difference and common ratio when we were talking about whether the sequence was arithmetic or geometric. D means it's arithmetic and you're adding something to get to the next term. R means that it's geometric and you're multiplying by something to get to the next term. So that's just a quick introduction of the formulas. You will use these formulas in all of the problems that you do in this section. So just a quick recap, a sub n is the nth term. A sub 1 is the first term. N is the term number. D is the common difference. And we use D when we're talking about an arithmetic sequence. And R is the common ratio. And this is lesson 2, finding the nth term of arithmetic and geometric sequences. So in lesson 2, we're going to be finding specific terms of a geometric or arithmetic sequence. Sometimes they may ask you to find something like the 5th term. Well, certainly if they just ask for the 5th term of this sequence, first of all, we have to determine is it arithmetic or geometric, and then we'll have to add that common difference or common ratio until we get to that term number. And so we've already been given 3 terms here, so it's not real hard to find the 5th term. We just need 2 more terms. So for this one, first of all, let's see, to go from 5 to 7, I've added 2 here. So it looks to me like that's arithmetic with a d value of 2. And so if that's arithmetic and they just ask for the 5th term, well, then we're just going to add 2 more times. So like the 4th term is going to be 11, the 5th term is going to be 13, we've found our answer. So that's really simple to do. What if they give us something like this and they say find the 6th term? But first we need to decide if this is arithmetic or geometric. So let's try arithmetic first. 2 plus what gives you 4? Well, that would be 2. 4 plus 2 is 6, not 8. So we know it's got to be geometric. If it's geometric, that means we've multiplied to get to the next number. So remember, we said in the last section that if we take a term and divide by its previous term, that will give us our R value. So 4 divided by 2 is 2. So we think R is 2. So 4 times 2 is 8. And yes, that's true. R is going to be 2. So to find the 6th term, well, this isn't too bad. We already have the first 3. So the next term, the 4th term, would be 16. The 5th term would be 32. The 6th term would be 64. Pretty easy to find a specific term number. But what if they ask us to find something like the 80th term here, or something like the 25th term here? I don't know about you, but I don't want to have to do this 100 times or have to do this 28 times. There's got to be a better way. And in order to do that better way, we have to know about the formulas for arithmetic and geometric sequences. In lesson 2, we are using the formulas for arithmetic and geometric sequences to find a specific term number. In the arithmetic sequence, where a sub n equals a sub 1 plus n minus 1 times d, a sub n is your final answer, your final amount, your whatever term number it is. So if you're looking for the 10th term, your a sub 10 would be the 10th term. A sub 1 is the first term in the given sequence. N is the term number of the term that you're looking for, and then your d is your common difference. For the geometric formula, again, a sub n would be the term that you're looking for. So if you're looking for the 10th term, a sub 10 would be the 10th term. A sub 1 is the first term in the sequence that you've been given. Your r is your common ratio, and remember to find the common ratio, we take any term in the sequence and divide by its previous term. And then n here is the term number that you're looking for. We're, in the first example, going to find the 52nd term given the sequence 30, 20, 10, and so on. So they want us to find term number 52. So in other words, I need to figure out, first of all, is this arithmetic or geometric? We have to figure that out first so that we can figure out whether we have a d, a common difference, or an r, a common ratio. And so looking at this, it looks like each time it's decreasing by 10. So I would say that this is arithmetic, and we're adding a negative 10 each time, right? We're subtracting 10, so that means we're adding negative 10, means the same thing. So this one is arithmetic. That means I'm going to use the arithmetic formula. So once you figure out whether it's arithmetic or geometric, and whether you have an R or a D, you then know, that gives away which formula you're going to be using. We are looking for the 52nd term. So I'm looking for a sub 52. N is the term number that we're looking for. A sub 1, remember, is the first term in the sequence, so that would be 30. N, again, is my term number, 52. D is my common difference, which was a negative 10 in this case. I'm going to just do the math here. I will use order of operations to do that math. So the 52nd term is going to be equal to 30 plus 52 minus 1 is 51. And that's times negative 10. So a sub 52, the 52nd term, will be 30 minus 510. My 52nd term is going to be a negative 480. In this one, it says find the 12th term given the sequence 36, 18, 9, ... So first, we have to determine if this sequence is arithmetic or geometric. So if we look at it, to go from 36 to 18, if it's arithmetic, we're subtracting 18. If we subtract 18 from 18, we would get 0, so we know it's not arithmetic. 36, 18, 9, let's see, if we take 18 and divide it by 36, we have 1/2. If we take 18 and multiply it by 1/2, we would get 9. So our common ratio here is 1/2. We know that this one is a geometric sequence. So R is 1/2. Since we've determined that it's a geometric sequence, we know we're going to use this formula. So a sub n equals a sub 1 times r to the n minus 1. To plug into that sequence, a sub n, remember n is the term number we're looking for. So we're looking for a sub 12, or the 12th term. A sub 1 is the first term, so that would be 36. R is our common ratio, or 1/2. N again is the term number we're looking for, so n would be 12. So to solve that, we have a sub 12 equals 36 times 1/2 to the 11th power. Now there's no reason that you can't just put this into Desmos just like you see it. Put 36 and then in parentheses 1/2, and that 1/2 is to the 11th power. Do it all in Desmos at once, and then you don't have to worry about what this term is. It's going to be a really, really small fraction. In this one, they're asking us to find the 28th term, given the sequence negative 23, negative 10, 3. Okay, looking at that, I'm going to check to see if it's arithmetic or geometric first. Let's check for arithmetic. Negative 23 plus 13 would give us negative 10. Negative 10 plus 13 would give us 3. So it looks like it's arithmetic, where D is 13. If we know it's arithmetic, we're going to use the arithmetic formula. A sub n equals a sub 1 plus n minus 1 times d. And that formula will be used for any arithmetic sequence. Then we'll start plugging in. We want the 28th term, so that means n is 28. So we've got a sub 28. A sub 1 is our first term, negative 23. N again was 28 minus 1, and d we said was 13. You're going to use order of operations to solve this, and just like before, if you want to plug all of this into Desmos, just like you see it, it will compute the order of operations for you. You don't necessarily have to do it by hand. When I do that, I get 328. In the next example, they ask us to find the 10th term given the sequence 5, negative 10, 20, negative 40. Right off the bat, I notice every other term is negative. So that tells me that it's not going to be arithmetic. There's no way for an arithmetic sequence to have every other term negative. So I know it's going to be geometric, so I need to figure out what r is. Remember, anytime you're trying to find r given a sequence, you take a term and divide it by the term in front of it. So negative 10 divided by 5 would be negative 2. You can do it here. 20 divided by negative 10 is negative 2. Negative 40 divided by 20 is negative 2. It doesn't matter which ones you pick, that will give you your ratio every time, so your common ratio every time. That is a negative 2. So we're going to use the geometric formula. So a sub n equals a sub 1 times r to the n minus 1. N is 10, so we're looking for the 10th term. So I'm finding a sub 10. A sub 1 is the first term, which is 5. R is our common ratio, negative 2. N, again, was 10, and we have 10 minus 1. So if I do the math there, I get negative 2,560. Here I've got two examples. I want you to do these on your own. Pause the video, get them down, and then I will give you the answers in a few minutes. So here are your answers. In the first one, I recognized that every other term was negative, so I knew it had to be an r, and 10 divided by negative 5 is negative 2. That is what my r value is. So I used the geometric sequence formula. A sub 18 equals a sub 1 is negative 5 times negative 2 to the n, which is 18 minus 1. And then when I put all that in Desmos, I get 655,360. In the next one, I need the 38th term. First, I checked to see if it was arithmetic or geometric. If I go from negative 2 to 0, my r value would have to be 0, which is not going to be the case here. So I knew it had to be arithmetic. So negative 2 plus what gives me 0 would be a 2, and 0 plus 2 gives me 2. 2 plus 2 gives me 4, so I knew it was arithmetic with d equals 2. I used the arithmetic formula. I'm looking for a sub 38, or the 38th term. A sub 1 is negative 2. N is 38, I got minus 1, and then times d, our 2 value, and that gives us the 38th term to be 72.